Okay, let's go ahead and get started. So, uh, last episode we covered reading files. So, reading files, just to go over it, we read slices of bytes from some source. So this time we'll cover writing files. I'd hoped to initially cover reading and writing files in just one kind of stream, but it looks like it's going to have to cover two streams. So let's start with writing a file. And we'll need to use reading a file to be able to test our results, so it's good that we covered that first. So let's start with, we need some text data to write out. So let's have a message, and we'll set that equal to, we'll go ahead and put it in byte form. Well, actually, let's leave it as a string. And we'll call it, say, hello, excuse me, hello world. And we are going to write this to a file. So we need os dot, last time we used the open call to open a file. This time we will use the create call to create a new file. And if we look at the description, it creates or truncates the name file. If the file already exists, it's truncated. If the file does not exist, and it is created with 666 mode. So if you're not a Unix person, that means it is readable and writable to everyone. So let's go ahead and create message.text, and that's going to return back a file and an error. Let's go ahead and check the error. At this point, we can bail, right? Because if we don't have it open, let's log. Actually, let's use log. So I don't believe I did this last time. So let's use log fatal, and that should exit us out when we after printing the log message. So error creating file. So if there was any problem creating the file, actually we don't need the new line, but if there's any problem reading the file or creating the file, we'll go ahead and exit our program, because there's no point in going on, right? Okay, great. So now we're going to, as last time, we used the defer call, say, okay, close the file when I'm done with it, meaning that I've left this main method. So let's go ahead, defer file.close. Okay. That way, if we, normally we're not in the main method. Normally we're in some method like write my message, and we don't want the file to be left open after the method completes, because the garbage collector may not collect it for a while, if ever. And if we open up too many files and just leave them lying around, eventually we'll run out of the OS that we're on usually has a limit as to how many files a given program can open, and we'll hit that limit. So we go ahead and say, okay, when main is done and you return from main, go ahead and run this. Okay, great. So now we're going to file.write. And we're going to go ahead and write message. Now again, just like reading takes a slice of bytes, writing, you'll see, takes a slice of bytes. So we're going to go ahead and turn our string into a slice of bytes. And this returns back the bytes written and an error. And again, we're going to check the error if error not equals nil. And this time, we're not going to go ahead and we're not going to do a log fatal. Well, actually, let's go ahead and do a log fatal, because there's no point in continuing, right? Error writing to file. and we'll go ahead and use log. Printf wrote. So let's go ahead and open a terminal. Run this. Okay, I wrote 11 bytes. Great, I wrote 11 bytes. But if we look up here, we see our message.txt file. So let's go ahead and open our message.txt file, and we see our message, hello world, in the text file. Awesome. Let's go ahead and delete that. Yeah, let's go ahead and delete that. All right, let's go and look at the other ways we can, the other forms of OS create. So we used OS create. However, there is OS oops. So what I'm looking for. Yep, open file. Open file. Open file does a few more things. So with open file, we have a string, a name, and a flag and a file mode. So if we look at the parameters, this is, so open and create are kind of convenience functions, so we don't have to use this full version. It it opens a file, or if necessary creates a file, or if necessary truncates a file, and with the given permissions we set for it. So for example, when we used file create or OS create, we got a file that was readable and writable by everyone. We could, using this one, just create a file that's readable and writable by ourselves. Maybe we want to only append to a file. So this would allow us to pass in the append flag, and instead of truncating a file, meaning we cut the file back down to 0, we go ahead and add additional stuff to the file. So let's go ahead and use this. So we will use, for our flags, we're going to use os dot create if it doesn't exist, and then we'll use the OR operator to combine these flags together. I'll cover the OR operator later when I cover bit operations. For right now, just take it as a way we can combine these flags together. I want it to create, or I want it to append. So if the file doesn't exist, create it. If the file doesn't exist, append to it. And I want a flag of, I don't want everybody to read it, so I want a 0. It's okay if people in my group, in my Unix group, read it, so that's a 4. And finally, I could read and write to it, so that's a 6. 046. So if I run my program again, oops. Oops, 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 oops. Mode. check the permissions. What's going wrong here? It is readable, but it is not writable. Interesting. Oh. Yes. Here we go. There we go. So this should this time. There we go. Okay, that fixed it. Now, for some reason it's not giving me the permissions I want. Let's try going back to default permissions. Weird. Okay. I'm obviously doing something wrong and I don't see it. Okay. All right, it doesn't give me the permissions. So this should be um, okay. So there is excuse me, there is uh, a type of masking that can go on in addition to the file mode that I set, where the operating system decides that, hey, we're going to mask off certain permissions so that uh, even if you ask for a file to be readable and writable by everyone, we're not going to allow it. That's called the UMask. So if you're working on Linux or you're working on Mac OS and you create a file and you give it a set of permissions and the permissions are not what you expect them to be, you can check the UMask. And so I think if, see what our UMask is. Nope, we don't have it set. All right, so anyway, let's get back on track. So this is the more general form of the open and create calls, which are functions. This is kind of the real thing that's going on under the covers, and the create and open just set different flags. So by default, if you open a file, if you just use the open call, you don't append, you truncate. So by using append, if I run this a whole bunch of times, sorry, and I look at my file, I see I've written hello world a bunch of times. And let's go ahead and add a nice little line terminator there to make life nice. And if we go ahead and remove it, and let's run it a few times. See, now we added the line terminator, we're writing 12 bytes. So let's go take a look at our file. Okay, we've got hello world in there a few times. Now, let's go ahead and move this in its own function. Let's call this function write file. And we're going to just using this to kind of hold the code, and we're going to go ahead and read that file now. So now we're going to do file error. We're going to just go ahead and use the open call here. Well, we could use the open file. So we want to error if we can't read the file. So we're going to open it in read-only mode. I think we want exclusive is not what I think we want. I think we just want read-only. And when you're opening a file, the permissions don't really matter. So if error not equals nil, we can go ahead and log not fatal. All right, so we want to go ahead and read this thing a file at a time. So buff.io dot and we're going to pass in our file as our reader, and we'll call this reader. Does this return a possible error? No, it does not return the error. Okay, so we got our reader, and we're going to go ahead and read. We don't want to use read line. We want to use read string. Let's use read string, and our delimiter is going to be the new line. So message is equal to read string, and this returns two values, a string and possibly an error. And again, the error is, so if we read the documentation, it finds the delimiter and if it runs into an error, it reads the data up to the point where it got the error. So let's do this. Let's do the for loop for error equals nil. And we're going to go ahead and log println message error equals reader dot read. And if message, we don't have an empty string, go ahead and log. Okay, so what's this doing? We did this loop the last time where we primed the loop once by reading the string, and that sets an error in a message. And while the error is nil, there's no error, go ahead and print out the message and read it again. Now, because of the way a read string works, when we get to the end of the file, the error will be set to EOF, or end of file. Excuse me. And the message will have the data we've read thus far. So if we're saying here is if the message is empty, don't do anything. But if the message is not empty, go ahead and print the contents of any message that you read until you got the error. Okay, so this, if we go around this, we see our message printed hello world. Now we see some extra space in there because read string will read. So there's a new line at the, let's go ahead and view, I don't see it. Anyway, if you were to look at this, if you were to look at the binary, you would see that there is a new line character, even though it's not no character showing on our cursor after our cursor, but there's actually a new line character at the end here. So because there's a new line character at the end there, because we wrote one out, right? So at the end of the day, when we read this back in, we get our new line character and we're seeing it printed out over here. If we didn't want to see the new line character, we could go ahead and trim it off the end. So we could say message equals message, or we could say println strings. We're going to bring in the strings package, and that has trim in it. And so trim has two things. It takes a string and a cut set and returns a string. And so the thing that we want to cut out are new lines. And strings.trim. So if we go ahead and do this trim, what trim does is it returns back a string with whatever's in the cut set removed from either the front or the back of the string. So if we've got, this is a good way to remove trailing spaces or leading spaces and data, whatever. But we're just going to go ahead and trim off the new line. And now if we run it, we'll see there. We got rid of that trailing new line. Okay. All right. So that covers writing as well as reading files. The big thing to take away from this is if we look, let's go ahead and take a look at if we go ahead and let's go ahead and look at the IO package. If we look at read, the reader, if we look at the reader interface and the writer interface, we see that they take streams of bytes. And this is actually by design. This is not kind of like, oh, well, we just need to have the lowest common denominator. It is actually by design. So everything that you want to read and write to a file, including like what we did and read and write this thing to, read and write data to the let's go ahead and look at the handler func. Nope, it's not the one we want. Loving this. There we go. All right, if we go back to net HTTP and we take a look at the handler func type, the handler func is anything that takes a response writer and a request. And if we look at response writer, we see that it writes a slice of bytes. So anytime in Go that you see something that reads or writes data to some source, you'll generally see it taking a slice of bytes. And we kind of all agree on that. So let's do something interesting. Let's say we wanted to create an uppercasing writer. So let's go ahead and create a type struct uppercase writer. And what we care about is the thing that we create it with is a writer. So let's call this destination, and it is a type of IO dot writer. Okay, let's go ahead and remove message.text. Okay, now let's go ahead and implement the writer interface for this. So we'll say func and again, write takes a slice of bytes and it returns back an int and an error. So we can double check that. So int and error. So let's go ahead and say uw.destination.write, and we're just going to go ahead and return that. Okay, but before we do, we are going to uppercase the data. So this is only going to work for strings, right? If it were binary data like an image, it wouldn't work. But let's go ahead and upper. And we can just go ahead and just upcase. And we can go ahead and sorry. There we go. So what's this doing? This is creating a struct that's got a writer, that's our destination. If we write some data here, we convert it back to a string, we uppercase it, and then we write it to our destination. So now if, let's call this read file, and let's move this all up into read file. Okay, we've got read file, we've got write file. So let's go ahead and write the file. But this time what we're going to do, and so let's go ahead and write the file. Okay, if we look at messages.txt, we see that it's lowercase. So let's go change this. To create a new, sorry about that, scrolling a little muddy. Let's go ahead and create a new uppercase writer. And for destination, we'll use our file. Okay. So now we substitute that with an uppercase writer. And with that one small change, let's go and see the next message we printed was all in uppercase. Okay, so if we all adhere to the same kind of interface for reading and writing data, we can kind of take whatever we're writing as. So let's say, for example, before we write the data, we want to compress it or encrypt it. We all use the same kind of interface so that as we pass, we can kind of wrap the existing readers and writers to do whatever other additional work we need to do. It could have been that I wanted to log the number of bytes read. It could have been that I wanted to, change the data in some way, or log the fact that I had written the data, whatever it is that I want to do. But essentially, by adhering to the same kind of general interface, we can all kind of wrap these things in each step. So if and this is where I'm getting at, and eventually I'll get to in this series of how to program videos. We'll be taking data, be encrypting it, we'll be compressing it, writing it to a file, then when we read it, we automatically uh, decrypt it, decompress it, and we'll be able to read it. And we'll do this because we all implement the same reader writer interface, and each stage is kind of transparent, and we can remove a stage, we can change one out. And that's the benefit of using a kind of standard interface like this, even though you might be from a language where you typically have a writer and that writes strings and maybe integers and maybe floating point numbers as different methods. Go has kind of a more straightforward approach. Everything's a stream of bytes. All right, that is it for today. And I think the next one will be on extending this to maybe go back to doing something useful where we'll extend kind of our um, web kind of our web project to read and write some HTML files or something. Anyway, that's it for today. I'll see you next time.